Geometric sequence. Geometric sequence is a sequence obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms. It is also a sequence which we can get the succeeding term by multiplying the previous term to the fixed number called the common ratio. Common ratio is the constant number multiplied to get the next term. For example, we have here number 2, 6, and 18. So 2 is our a sub 1, 6 is our a sub 2, 18 is our a sub 3. And we will find the next term, which is the a sub 4. So we will first get the common ratio. In getting the common ratio, we will use the equation ratio equals to a sub 2 divided by our a sub 1. So this will become ratio equals to a sub 2, which is 6 divided by the a sub 1, which is 2. 6 divided by 2 is 3. So our common ratio is 3. So to get the next term, we will multiply the a sub 3 to the common ratio. Our a sub 3 is 18, and we will multiply it in our common ratio, which is 3. 18 times 3 is 54. So our a sub 4 is 54. What if we are asked to get the 12th term in the sequence? In getting the 12th term, we are free to use this equation that we will get the common ratio and multiply it by the last term given to get the next term until we can get 12th term. But we also have a shortcut. In getting using the shortcut, we will use the equation a sub n equals to a sub 1 multiplied by the common ratio raised to the n term minus 1. Our given is 2, 6, and 18. 2 is our a sub 1, 6 is our a sub 2, and 18 is our a sub 3. And we will find the 12th term, or a sub 12. Our a sub n is 12 because we are looking for the 12th term. Equals to our a sub 1, that is 2, and our common ratio, which is 3 raised to the n term, which is 12 minus 1. We will first get or answer the exponent. So a sub 12 equals to 2 times 3 raised to 11. Next, we will answer the 3 raised to 11. It will be a sub 12 equals to 2 times 177,147. Next, we will multiply the remaining numbers. 2 times 177,147 is 354,294. So our 12th term is 354,294. So in finding the n term of a geometric sequence, we will use this formula.
Geometric series. Geometric series is the sum of a geometric sequence. The formula in finding the sum of the first n term of a finite geometric series is Sn equal to a sub 1 times 1 minus where Sn equals the sum of the first n term. A sub 1 equals first term, n equals the number of terms, r equals common ratio. We have here example. What is the sum of the first 10 term of the geometric series 2, 4, 8, 16? Our first term, or a sub 1, is 2, our nth term is 10, and our common ratio is 2, because second term divided by first term, which is 4, divided by 2 is equal to, so 2 is our common ratio. And now, let's proceed. Our formula Sn, or the sum of the n term, equal to the first term times 1 minus the common ratio raised to the nth term divided by 1 minus the common ratio. This will become S10 because we are looking for the sum of the 10th term, equal to our a sub 1 is 2 times 1 minus our common ratio, which is 2 raised to the nth term, that is 10, divided by 1 minus our common ratio is 2. Our next step is let's focus on the exponent is 1024. It will become S10 equals to 2 times 1 minus 1024 divided by 1. Minus 2 is negative 1. So this will be negative 1. Next is we will answer what is inside the parentheses, which is 1 minus 1024. It will be S10 equals 2 times negative 1023 divided by negative 1. Next, we will multiply the number outside and inside the parentheses, which is 2 times negative 1023. Will be S10 equal to negative 2046 divided by negative 1. Lastly, negative 2046 divided by negative 1 is positive 2046. So, the answer or the sum of the 10th term is 2046. So, in finding the sum of the first nth term, we will use this formula.
Arithmetic sequence.
Arithmetic sequence is a sequence obtained by adding a common difference d to the preceding term in order to obtain the next term. Arithmetic sequence is also known as arithmetic progression. Example, we have here a pattern 3, 8, 13, and 18, wherein our a sub 1 is 3,
A sub 2.
8, a sub 3 is 13, and a sub 4 is 18. All of these have common number, which is you're going to add that number. Then you will get the next term. In getting the fixed number or the common difference, we will subtract the preceding term to the previous term. Or we will use the formula d or the common difference equal to a sub 2 or the second term minus a sub 1 of first term. So d equal to a sub 2, which is b minus the a sub 1, that is
8.
So 8 minus 3 is 5. So our common difference in this sequence is 5.
So if we are going to add the common difference in the last term given or the fourth term, which is 18, the next term or fifth term will be 23.
Because 5 plus 18 is 23. What if we are asked to get the 15th term of the arithmetic sequence? In this situation, we are allowed to use the last formula that we will get the common difference and add it to the last term until it will get the term needed.
But we also have a formula for that, and that's an or the last term equal to a sub 1 or the first term plus n or the last term minus 1 times d or the common difference. Our an is 15, so this will be a15 equal to 3, our first term, plus our n minus 1 times the common difference 5. Let's answer first the parentheses. So a15 equals to 3 plus 15 minus 1 is 14. So this is 14 times 5. Next is we will multiply this. 14 times 5 is 70. So a15 equals to 3 plus 70. So 3 plus 70 is 73. So a15 is equals to 73. So in obtaining and getting the next term, we can use the first formula or this formula. Arithmetic series. Arithmetic series is a series or summation that sums the terms of an arithmetic sequence. The sum of n terms of an arithmetic sequence a sub 1, a sub 2, and a sub 3 is denoted by Sn. If you are asked to find the sum of the 10th term of the given sequence, we will use this formula. Sn or sum of the n terms equals n or the n term divided by 2 times a sub 1 plus n or nth term minus 1 times d or the common difference. So we will use the arithmetic sequence 4, 9, 14, and 19, and our nth term is 14. So the first term or a sub 1, this is the a sub 2, a sub 3, and a sub 4. So now, we will simplify it. It will be S14 because 14 is our nth term equals 14 divided by 2 times 2 times our a sub 1 which is 4 plus our nth term 14 minus 1 times our common difference that is 5. So S14 equals 14 divided by 2 is 7. So this is 7. Let's answer first all the numbers that have or in the parentheses. So 2 times 4 is 8. So here this is 8 plus 14 minus 1 is 13. Then copy times 5. So next, we will multiply again the numbers that are in the parentheses. So this will be S14 equals 7 times 8 plus 13 times 5 is 65. So this is 65. Next is let's add these two numbers. So S14 equals 7 times 8 plus 65 is 73. So this is 73. Next is we will multiply the remaining numbers. So 7 times 73 is 511. So the sum of the first 14th term is 511. In finding the sum of the terms of an arithmetic sequence, we will use this formula. But we also have another formula in getting the sum of the terms of an arithmetic sequence. It is Sn, or sum of the n terms, equals n divided by 2 times a sub 1 plus a sub n. But we can only use this formula if the last term or the nth term is given. Example, our arithmetic sequence is 4, 9, 14, 19, 24, 29, 34, 39, 44, 49, 54, 59, 64, 69. Or it can be written as a sub 1 equals 4, a sub n equals 14, and the 14th term equals 69. So the formula is Sn equals n divided by 2 times a sub 1 plus the a sub n. This will be S14 equals our n, which is 14, divided by 2 times our a sub 1, that is 4, plus our a sub n, or the a sub 14, which is 69. So next is we will divide these two. This will be Sn equals 14 divided by 2 is 7. And then times 4 plus 69 is equals to 73. Next, we will multiply the remaining numbers. So 7 times 73 is 511. So the answer is just the same as the first formula, 511. But remember, we'll just use it if the last term is given.